Hello everyone. This is the solution video to assignment 5 Digital IC Design NPTEL 2024. So let's go over this question by question. Right. So in question 1 we are given that P dyne is the dynamic power of a circuit running at a frequency F with supply voltage VDD, and if the frequency is increased to 4F, then what should the supply voltage be changed to such that uh, the dynamic power is only 2 times P dyne, right? So for that the working is on the right hand side, right? You will find that N is equal to 1 by root 2, right? So you'll have to reduce it to around 71%. Next, if a transistor A displays 1/4 the standard deviation in VT as transistor B and both transistors have a length of 30 nanometer, then what is the ratio of the widths? So we know that sigma VT is inversely proportional to root over WL, right? So therefore the ratio of the sigma VTs will just be the ratios of root over WLA and WLB, right? And we are given that ratio, so therefore from that we are also given that LA equal to LB, so therefore we just get that the answer is 16. Next, which of the following statements about static CMOS inverter are true? So I have given the three situations described as A, B and C as diagrams on the right. So in A, the NMOS has leakage, so therefore when the output is logic high, that is when the PMOS is trying to pull it up to VDD, the NMOS will be off, but it will be leaking in some ratios, so you won't get a proper you won't get a proper VDD, you won't get a proper logic high. In situation B, you won't get a proper logic low for the same reasons, right? And in situation C, right, you can have that just due to leakage, the logic low is affected so much because the PMOS is leaking and it's a very strong device, and the NMOS is not leaked well. The NMOS is on, but it's very weak. So therefore, there's now a fight between the PMOS and NMOS, and once there is a fight, it just depends on the ratio of strengths, and eventually for large enough PMOS size, there will be large enough PMOS leakage, and it could affect the output logic low, right? So that is situation C. So the answer is A and C are true and B is false. Next, three inverters are connected to form a ring oscillator, right? So you have the delay of three inverters as the frequency of the circuit, as the time period of the oscillation, and so the frequency is 1 by the time period, right? So F is equal to 1 by 3 into 8 nano to 2. So 2 because it takes 2 rounds around the ring oscillator for one period of the waveform. Right, over here we have five inverters connected in a ring oscillator. We are asked to find the dynamic power. So the dynamic power is just complete. It comes completely from the capacitance going from 0 to VDD. Right, so the frequency is and it's just a matter of dynamic power is 5 times the dynamic power of, since all the capacitances are the same and all the inverters are the same, each capacitance will have the same dynamic power. So it's going to be 5 into PC, right? So 5 times C VDD square F, and that just works out to 10 microwatt. So in question 6, we are basically given this circuit, right? Right, and we are asked to find out what frequency N3 oscillates with, right? So I have labeled the nodes N1, N2, and N3 as inputs to the XNOR gate, right? And we can imagine the I have drawn the waveform for clock 1 and clock 2 over here, right? And you can what I've done is I have labeled the edges of the clock as with the number n. So the first edge of the clock is n equal to 1, the second edge of the clock is n equal to 2, that is the rising edges of the clock, right? So what you can see over here, right, is with some initial conditions, what is the value of y, the output of the NOR gate, right? So the point is this circuit, if you just work out what the output of that NOR gate will be, it will come out to be the following waveform, right? With a period of 4 clock periods, right? That will be the output of this circuit. In fact, I have given the expressions for n1, n2, n3 at any n, right? And you can see the expression of y with respect to any of its previous values, right? So y at any n just depends on its n minus 1, n minus 2, n minus 3 values by the output of that NOR gate, right? So an example of that is at n equal to 1, the value of y is 1 because it is the NOR of 0, 0 and 0, right? Similarly, at n equal to 2, the value is 0 because that is the NOR of 0, 0, 1, right? So that's how you get the output waveform for this circuit, and it is periodic with a period of 4 clock periods. So therefore, this whole every node in this circuit, since every other node in the circuit like n1, n2, n3 are just buffered versions of y, right? We'll get that all the other nodes are also simply delayed or you have 1 period delayed or 2 period delayed versions of y, right? And therefore they all have the same frequency and the same waveform, just with some delay. So the dynamic power will not change on all the nodes in steady state, right? So the frequency at which, first of all, the frequency at which this node N3 oscillates is the same as the frequency at which node Y oscillates, which is 1/4 the original frequency. Basically, it takes 4 clock periods, right? So 1/4 the original, or 1/4 the clock frequency. So the point is, it has a frequency of 4 gigahertz, right? The clock has a frequency of 4 gigahertz, so 4 divided by 4, that's 1 gigahertz is the answer. And then to get the dynamic power, you just have to look at all the capacitors in that circuit and see that they all oscillate at a frequency of 1 gigahertz. And so it will be 7 times CVDD square F, that will work out to 28 microwatt. Right? So this is the answer for question number 8, right? So if there is no subthreshold leakage, no dibble, and so on, then for this zone, basically the slope of the graph will be equal to 0, and that's basically what we are asking, and so the answer is 0. So this is the inverter's transient response with input A and output Y. We are asked basically T rise, T fall of A and Y, right? So the formula for T rise and T fall of A and Y are given over here, and the calculations are also performed. The answer is 20 pico, 20 pico, 23 pico, and 25 pico. Similarly, TPHL and TPLH, right? So the next question is asking for TPHL and TPLH. That's basically the output node, TPLH and TPHL. And again, I've given the formula here for both of them, and this is the calculation. It comes out to be 3 pico and 5 pico respectively. So that is the answer. And with that, we come to the end of assignment 5. Thank you.